Hello and welcome to a new video. My name is Herwig Juster and today we discuss the motivation for using regrind in plastics, what to be aware of when using regrind and which levels of regrind can be applied. So let's start with the motivation to use regrind. So in general, regrind is used to mix it with virgin resin or completely use it for new parts to decrease the thermoplastic resin costs. And when you think, one common source for obtaining the regrind are sprues from molded parts. So you collect them after injection molding. After the injection molding project is set up properly, so everything is running, you have a stable process, and then you can start collecting the sprues. However, when you think, also rejected parts in your molding process can be transformed to regrind. So you have on the one hand good parts and then the sprues to collect only the sprues, but when you have parts which are not okay, you can also use them, make a regrind out of them and add it to the virgin resin. An important point is the thermal history. So it's the next point with regrind to take care of. So by adding regrind, the thermal history is important. High melt temperatures in combination with too long residence times in the plasticizing unit can lead to thermal degradation of the plastic itself. So when you think of adding the first time 20% of regrind to the virgin material, everything can be fine. However, when you use then the sprues of these parts, which is a combination of 20-80% and adding new regrind, decrease of mechanical properties due to the thermal degradation may occur. So this is something to keep in mind. So therefore it is also important to contact your resin supplier and check how often a chosen thermoplastic can be molded without losing its mechanical properties by more than 10%. So this is also a general rule of thumb. When you're still in this 10% loss, everything is still fine. Okay, now the ratio of regrind. So what does the literature say? What is also my experience saying? So the amount of regrind added to the virgin resin can be between 20 to 25%. And this ratio is valid for most plastics. And in molding operations, some parts allow even using 100% of regrind. And there are other parts which allow only for 100% virgin materials in certain industries, healthcare, medical, and so on. And the use of 100% of regrind, this will be the case also in that example of the bottle opener, which we will discuss next year. Okay, here I found a good example to demonstrate the potential of using regrind. And this is a bottle opener you can see here, and here it's a stress analysis. And in this study, the effect of material selection on the sustainability of plastic injection molded part was evaluated. So on the beginning of the study, they made a material selection for the bottle opener, which led to a short list of 3 materials. It's mainly a ABS, a PLA, and a polypropylene with 30% glass fiber. And each of those material was then studied at 6 different regrind variants. Just a word to sustainability. So sustainability always includes several aspects, and mainly represented by the 3 pillars: environmental aspect, economic and social impact. And when you put now sustainability in the context of this analysis, it was also clear to note that no particular material was superior in terms of all these three pillars mentioned before. So each of the materials has several advantages but also disadvantages. And therefore it was also for the authors there difficult to rank the materials in order of preference in terms of sustainability. Okay, let's have a look at some of the results. So here are now the free material. In blue the ABS, in red the PLA, and in green the polypropylene with 30% glass fiber. And we have here the percent of regrind starting from 0 to up to 100%, and then the force which is needed to break the part. And as you can see, we have barely, we are staying also within this 10% of loss of mechanical properties, which is really good. So in this case, this part can be really used for to use 100% regrind even. And so all over the polypropylene with the 30% glass fiber with 100% regrind is the option to go forward, evaluating all the results they found. And because also when you think of cycle time, cooling time, along with other processing parameters. And what is also interesting, the cost situation. So this you can see here, total costs, and again the percent of regrind. And when you get 100% regrind, the polypropylene is really unbeatable, but also all the others. So we really move from down to 1,000 and starting from almost 5,000. So it's really a huge reduction. And for me also interesting to see is that the regrind content did not have any effect on, they looked also at energy consumption, on the quality of the bottle opener and so on. Because when you look into literature and also out of my experience, the quality results of parts with 30% or more regrind content would be inferior to parts made of the virgin material. However, this is not the case here in this bottle opener part, and it's also good news for all the people manufacturer that produce parts of similar size, material and also function. And because it will allow us to make use of regrind material, not only to make a cheaper than the virgin material, but also to consider it as a sustainable option, both for environmental and for social. Okay, so if you want to have more information on polymer engineering topics, such what we discussed before, check out my blog, vanadaboutbasics.com, and also on material selection I created online courses. I will link you both the blog and the online courses in the description below. Okay, which video to watch next? In this video I show you how to simply estimate the extrusion residence time by using an online tool. Thank you for watching, and do not forget to subscribe and smash that like button. Till next time, bye.